You can do it however you want, but I find it easiest to, look at the products. As far as I know, you guys have only learned one reaction that gives you two separate products. Ozonolysis, there you go. So we know we're going to get this from ozonolysis. What does ozone react with? So, also, what was the rest of the workup? So we know we start with O3. There's actually another condition there. It has to be negative 73 degrees Celsius. Got to be really cold to work with ozone. What else do we need? Good call. So CH3 2S. There we go. So that's ozonolysis. What does ozonolysis react with? Chapter 6. What is Chapter 6 about? Reactions of alkenes. Reacts with an alkene. Where was our alkene though? We don't have any. Where was the double bond in our alkene? You guys remember ozonolysis at all? Yeah? So what ozonolysis does is if you have, let's say, 2-butene, you react that with O3 at negative 78 degrees C, and that's actually the second step. Then you actually cleave it all the way down the double bond. This. So the two carbons that were attached by the double bond aren't even stuck together anymore. They're completely separated. So that's where we actually get the division into two separate molecules.
Okay, if you were working backwards, then that step would be actually just connected to carbons.
Yeah, so we would just take the two carbons, and also the two carbons that were connected, so if we have two of these, they didn't have that double bond there before, right?
Right.
So we would take the two carbons that were connected, stick them together with a double bond, and get rid of these others. So that's 1, 2, 3, 4, 5, 6, 7 carbons long. 1, 2, 3, 4, 5, 6, 7. And the double bond is between 1, 2, 3, 4, and 5. So 1, 2, 3, 4, 5 right there. So that's what we reacted to get that. Suddenly it's all coming together, right? I'll draw that slightly further over because you're filling it.
And then the step before, you have to actually make it.
Yeah. And first we need to get it 7 carbons long. We already decided
right.
to do that, right? So we're going to get it to be 7 carbons long.
Get it 7 carbons long and use a 7-9 reaction.
Yep. You actually want to do 2.
Oh, because of the placement of the double bond.
So I'm not going to show both intermediates, I'm just going to show what 2. Oh, God. It's still just like 4 steps. It's a lot less than 9. Alright, so what 2 carbon chains are we going to want to stick onto this to get to 7 carbons with that? So this double bond is going to come from a triple bond, presumably, right? So if we think about a triple bond being there, there we go. Alright. So, assuming that our alkene came from our alkyne, what did we do to get that? To just mix the triple bond down to a double bond. What reaction did you do that? That's one of them. There you go. So we add a propyl. Yep. And what's the other one we had? Yep. An ethyl. So we already had 2 carbons. We had propane to one side and then ethyl to another side. That gives us 7, right? 3 plus 2 plus 2. And it also puts the triple bond between carbons 4 and 5, which is what it's going to be over there.
Wait, why do you have to do that step twice?
Because we're adding on 2 separate chains. We're adding on a propane chain to one side and we're adding on an ethane chain to the other side. We can't just add on like 5 carbons at once because that would give us a triple bond out here.
But how can you ensure that's to one side and then the other side? They're just both on one side.
Because once you've added one to one side, that side is no longer a terminal alkyne, so it can no longer undergo that reaction. At this point, this could add to either side, doesn't matter which because it's linear. At this point, one side now has a propyl group on it. This is the only acidic hydrogen we're going to have left. That's going to be the one that adds to the ethane branch. That makes sense? All right, so going from here to here, triple bond to a double bond. We know 3 different reactions that do that. But they all do it differently. Right? Well, we know 2 reactions that go from a triple bond to a double bond. As far as getting rid of pi bonds, we know 3 reactions. It could be, I heard H2 Lindlar catalyst. I heard, so there's also H2 over palladium. And what's the third one that we could do? Yep, so that one's out. There you go. What about this one? What does that do? Cis. Does it matter if we get cis or trans? It wouldn't, right? Because even if I drew this as trans, but it doesn't really matter. Because if this was cis, it would still do the same thing. But what's the other one we could use to get the trans? Sodium and...
Oh, sodium H3, yeah.
I always got that one and that one confused when I was in 301. And that cost me a lot of points in the exam. So don't do that. Yeah, NaNH2 and Na with NH3. So sodium amide with sodium and ammonium. Because they look really similar. And they're both alkyne reactions. So you could use either of these, not that one. Then it was analysis. So yeah, 4 steps. That wasn't too bad, right? Pretty good multi-step synthesis.